Okay, Math 9. We'll finish off our last lesson in Chapter 7, and we should be moving out of polynomials. Bad news is, that means we're heading into algebra. That's okay. If you have polynomials figured out, you're going to do quite well. All right, so here we go. Once you've been able to master this lesson, and you've done all your practice and gone through a few quizzes, you should be able to divide polynomials, or many terms, by monomials. If we back up a little bit to lesson 7.2, you were multiplying a monomial through your polynomials using the distributive rule. In this case, we're going to back up, and it's almost like reverse distribution. We're going to divide instead of multiply and see what we get. So away we go. A few ground rules first. Our tile colors need to be laid out. So our tiles, as long as they're these ones here, right? These are the ones that you would expect. These are positive tiles. We've got our x squareds, we've got our x to the first, and we've got our little fella here, right? Which is a really small one because it represents just one whole unit of value, a constant. Example 1, 2, 3, 4, 5, 6, or negative 1, 2, 3, 4, 5, 6. You get the idea. The positive y tile is a little bit different. This is why I'm not totally thrilled with color for this. So I'm going to make this work. This y tile, if you look at it, I'm going to mark it with a special Halloween color of orange. Sure, it'll be colored in. Now, what you have to realize about it is that it is shorter than an x tile. So I'll just borrow the x tile color just for a second because you see it above. Oop. Forgot I have to. There we go. You have to hit done before you do that. Now the x tile, which you saw above, is longer, right? It's about as long as one of the sides of those squares. So I need you to understand that a y tile is a little bit shorter, and when we use tiles for y, we end up making rectangles and not perfect squares because the sides will be different in length. And if you zoom in on it here, if this is one of our x tiles, the y tile is shorter by that much, and we intended for that to happen. When you use different variables, they don't have the same length. So this is a pretty smart way of showing you that the tile constructs that we make, they won't look the same. We won't be getting squares when we use y tiles. That is, unless we use other y tiles. But we'll come there soon enough. To the other side, what we've got are our negative values. We've already seen these. We let these be white in color. And we've got a stray here, so let's hit done. Instead of getting a square, when we set up a y tile beside an x tile, what we get, so we'll say it's y for height and x for width, it's a little bit shorter. The y value doesn't go nearly as high. So what happens is that gives us a rectangle, whereas over here we got a square. All right, so let's move forward with this example. It'll come up again and again as we do our work. And what we should point out here, if this is a positive xy tile, then we're going to have all sorts of fun labeling a negative xy tile. What that would have to be, it would have to have an absence of color. So I'll just use an orange outline, and I'll leave it like this. There we go. And fill in that last missing one that we didn't have. Now, just like when you multiply, if you multiply 3 times 2, let's change our color, go back to blue. If you said 2 times 3 equals 6, 6 is your product, so if you divide your product by one of your factors, you'll always get the other factor, right? 6 divided by 3 equals 2. So that's not much different than saying 6 divided by the other factor 2 equals 3. Let's just wanted to point that out. if we go back to our example, what we can say, you don't have to write this, just watch along, is that the product divided by any one of the factors equals the other factor. Again, I'm just scribbling this down. Okay, that's our 6 divided by 3 equals 2 example. The reason why I'm mentioning this is I want you to see that this here is the product, and this up here is one of our factors. So what's the other factor? The really neat thing about algebra tiles, to answer that question, is what shape would fit in on this side that would make this possible. I'll go to orange here because I'm going to need it. In order to get this xy, we've got 4 of them. First thing you have to realize is that's not a square, that's a rectangle. So it must have come from one of these shorter y rectangles, and I'll fill it in so we can see it a bit easier. There we go. And that's what produced for us these rectangles. Now they're not squares, so we can't say x squared and we can't say y squared. They're xy's. So here's our x's up here. And what must have been right here, let's hit done, and I'll go back and get my darker color back. There must have been a constant here, because we see that there is indeed, oops, undo. It's okay. I can fill that in. There we go. We see that what we get down here at the bottom is that we get an x and an x. So now that you can see it sort of all laid out, this had to be a y, this was a y, and this is a constant value of 1. Well, we just found the answer. Now it looks pretty complicated, but what you've said, let's scroll out because we'll need a little bit more space. Essentially what you've said is that 4xy's, let's see if we can find a place to write that. I think we can write that in blue. So we could say that 4xy's plus 2x divided by 2x's gives us our answer, which is 2y's plus 1. So there it is. There's our answer to this whole mess over here. Now, if you pause the playhead, and in section B there of example 1, figure out what the missing shapes would be. Just go by the shapes and then look at what you have afterwards. That's why this is a technique that's very positive. It works out quite well. So I'm going to get ready to go here too. So hit pause and come back in however long it takes you. Not longer than 5 minutes though. Okay, so I'm going to get going with this example. And I can see that these are squares, which means they must have come from x values. There we go. And these are our x-style thin little rectangles there. And they must have come from one of each of the above multiplied by our constants. But our constants must have been white because these turned white on us. So let's grab a color here. I'll just choose a nice, I don't know, I'll go with blue. So let's write in what we have. We've got x squareds, 6 of them in fact. That's why coefficients are so darn useful. It says how many of them you have. And these are negative x values. So our answer, let's just wall this off a little bit so we don't confuse what we were doing. Our answer is right here on the side. What is this? Because that's the answer to our work. Choosing a different color, I use a green. Push this off to the side, get rid of that. I'll write sideways. So what we've got are 6x squareds minus 6x, because there's 6 of them down here, right? So that's just me counting them up, just looking at what we have. Here we go. If you divide that, so I'll do a division sign, divide by 3 x's, then the other factor must have been 2x minus 2. There you go. There's our answer. So we can just look at what we saw over here. Okay. Now that is the model. Again, it's what we refer to as the area model way of solving this, and it works really well. You can put very complex expressions up, and as long as you use the tiles correctly and you figure out one of the missing sides, what you've done is you've done polynomial division. In this case, this last one, we divided 6x squared minus 6x, and we divided by 3x, and that was along the top. So our polynomial got divided by a mono, and lo and behold, we got an expression or an answer out of that, which turned out to be a binomial since there's 2 things in it. 2x minus 2. Okay. But there's got to be something scratching in the back of your mind saying, oh my goodness, am I going to have to draw tiles till the end of time? No, you don't. In fact, this is the traditional technique that I was shown. Worked pretty well for me. I've seen there's many a variation on it, but I like to do this interesting little scribbling technique, so I invite you to follow along with me. And let's go to scroll mode. So here we go. Now, actually, we'll come back to this. Sorry, I read that it says use a model to divide each expression. I'm going to show you the traditional technique, and then I'm going to come back. I did this in class too, because at this point, I'm pretty certain you can draw the model. But what I'm interested in is, would you like to see the easier way to do it? So here's something. I'm going to skip down to example 5. So flip in your pages a little bit to example 5. I am going to look at the coefficients, and I'll do my division as I need to, and I will also look at my variable terms, and I'll apply the exponent law. So I really only have 2 things in mind. Here's my challenge. 1, do some division with the coefficients if I can, and 2, if the variables are the same, I'm going right after that exponent law as quick as I can. Now I'll show you this and a couple of them, and then we'll back up and we'll look at the model, and you'll see how the 2 techniques have advantages and disadvantages. First thing you have to realize is that everything on the top is being divided by the bottom. So the 15x squared is being divided by 5x. So let's go for our colors here. So I'm going to show this very carefully. That division is happening, and at the same time, let's choose a totally different color. Let's choose some Christmas colors here. This division is happening. You see that the top and the bottom are both being divided, or sorry, rather that the top 2 terms are being divided by the bottom term. What that really means, if you'd like to write this out in full, is that you've got 15x squared being divided by 5x, and I'll keep the subtraction sign just like I saw it, 20x divided by 5x. Well, if you do a little canceling, right, the greatest common factor is 5 for each of these. So let's make that, I'm dividing by 5 here. Then what we've got is we're going to have 3x squared over x. So I'll just do the coefficients first. Minus 4x over x. Okay, now if you apply the exponent law, you're left with 3. Now, x squared, there's 2 on the top and there's 1x on the bottom. You'll be left with just a 3x minus 4. These x's will essentially cancel out and become 1. So there's your answer. Now, what I would have done is a little sneakier. I would have looked at this and said, just done this little sort of crisscross technique, and I'd look at this and I'd say, okay, right there, what we've got, let's choose a different color so we're clear, is we've got 3x, and then I would look at, let's choose our highlighter here, choose a different color. I don't know, maybe a little bit of orange, but turn the opacity down. There we go. And then I would have looked at this, like that. And I would have said, okay, so what we're left with, I've got my 3x, and negative 20 divided by 5 is minus 4, and the x's cancel. That's in one step. So if you can see that, you can do these questions with a lot of efficiency, and you could sort of pick up your pace a little bit. I'll move over to the next one, and I'll apply that technique that I just used because it's a little easier. And I'll do the little crisscross technique. So I'll think about that, and notice that I'm very aware of the sign. I mean, I'm even using different colors here to just make my point. See how I keep the positive sign inside of that. I want to be aware if there's any negative signs that change our basically change whether our values are positive or negative in our answer. So what do we have? We've got, at this point, 16 divided by 4 is 4, and m squared divided by m is just m. So there's your exponent law. So coefficients dealt with, exponents dealt with. On the other side, 20 divided by 4 is 5. Now it's plus 5, not minus 5, because there's no negativity, right? The answer on top is a positive value, so that's why this is a positive sign. The m's here will cancel and become 1, and you're just left with an n. So it's a very quick technique. It works out really, really well. And once you get going with this technique, I guess I'll just do D just because of space restrictions. You can really pick up a bit of steam. And I won't switch the colors this time. I'll just go like that. So 12 divided by negative 6 is negative 2, and the m's cancel. And then I look here, and this is 18 divided by negative 6 is negative 3. Again, the m's cancel, and I'm just left with n. Okay, so that's a fairly quick way to do a problem like this. Okay, so a math class just wouldn't be a math class without a couple of word problems. Example 6 and example 7, what you can anticipate coming up are polynomials divided by monomials. The hardest part about a word problem is drawing it. If you can draw it, it'll help you to understand it so readily. Now look, when I look through the information, I can find my polynomial there, and I can find my monomial there. I'll just hit done and go after this with a slightly different highlighter color. So what's the remainder? You're decorating a bulletin board. Okay, so that'll be a rectangular surface. Kind of sounds familiar. And each picture of the bulletin board covers that much right there. Okay, once I have this amount of information, I'm finding out that the area of the board is this, and each little picture is a tiny chunk of it, is a factor of it. So what I need to do, pop out to a blue color here, is to draw that bulletin board and get an idea of what it is that we're talking about. Okay, so rectangular bulletin board with an area of 4x squared plus 16x, and our area is in square units, okay, in this case centimeters squared. And they said each picture, so let's switch pen color, each picture itself accounts for a little tiny piece of that area, little tiny chunk. So if we're going to divide the area up by these little pictures, then what we have is one of the sides, which we'll represent with 4x. So essentially, let's show it like this. We're going to divide up this area by all of the little pictures whose area, so that little picture, is 4x. So how many of the little ones can make up the big one? Okay. Question like this, you put your smarts to work right away and you say, you know what, the easiest way to do this is that technique where you write the product like that over top of one of the factors. Now that's like saying, you know, one of the sides is 4x and you want to know how many of these little pictures will be required to make up the whole thing. Like how many would you have to line up? Okay, so using a crisscross technique here, let's see if I can go with this. There we go. We'll look at this first, like that, and then just choose a different color here, and then we'll do this second. So what do we have? Well, if we look at 4x squared divided by 4x, what we have is x. 4 divided by 4 is 1. X squared divided by x is just x. Plus 16 divided by 4 is 4. X divided by x cancels. Our answer turns out to be x plus 4. So when you look at this and you say, okay, so what does that mean? That means if each of these little pictures takes up an area of 4x, and if this is our larger area, if we divide up the larger area by the small area, we say that it must be x plus 4 pictures. Now that sounds a little bit weird, but if you take your factors and multiply them, they should give you the bigger area. So this was a kind of question where the big area got divided up by the area of all the small things, and that told us, believe it or not, how many of those small things we had. So I guess we could say x plus 4 pictures. With this area make up the larger area. Okay, Math 9, for our last question, just popping back here. For our last question, question number 7, we've got another rectangular sort of area question, and this one tells you the following information. Let's lay it out. That you've got a rectangular lawn. Okay, so we'll draw a rectangle like so, with nice curvy corners. And this thing has a width of 3x, and again, that's referring to meters. Okay, so the width is 3x, and the area, we'll underline the important information, is this expression here, 15x squared plus 45, and again, that's in square meters. Pay attention to the units, because when you see square meters, you know basically that you have the product to multiplication, right? Because length times width equals area. Let's write this information in the center. So your area, if you think of it this way here, I'll just sort of highlight it a little bit, is 15x squared plus 45x. So what they want to know is what's the perimeter of the lawn? Perimeter of the lawn, perimeter of the lawn. Now wait a minute. Isn't perimeter when you add up all the sides? Well, I already know one of the sides. And since it's a rectangle, that other side opposite must be 3x. So really, all I have to do is divide that area by one of the sides, and I'll know the missing side. That's exactly what it is. As soon as you know the missing side, you can fill in this entire rectangle because opposite sides are congruent. They're the same value. So let's get right to it. Choose a blue color now. So take your area, which is really nothing more than a product, and divide it by the factor that you know, 3x. So if we do our little crisscross technique here, there we go, and we might as well extend it over this way. What do we have once we do the division? Well, 15 divided by 3 is 5, and x squared divided by x gives us an x to the first term. Okay, this gets interesting. Now if we look at this one, 45 divided by 3 is 15. X divided by x cancels out. So we're left with 5x plus 15. Okay, so we just found out our missing side. 5x plus 15. Which means we know the opposite side. I love these kind of mathematical questions where once you find one thing, it just sort of leads you along to figure out the rest. It's kind of a little bit of Sherlock Holmes in a way. Follow the clues and figure out the mystery. So they want to know the perimeter of the lawn. Okay, well, perimeter means that we have to add all of these up. Now, using mathematics, we have to say what the final answer is. So what do we have? Well, we have a pretty big expression. We're going to need a little bit of room. Where am I going to put this? We've got 3x plus 3x plus 5x plus 15 plus 5x plus 15. So that accounts for every side. Now you want to do a little collecting of like terms here, and you sort of need to combine a few steps. We've got 3x, that's 6, and here is another 10. So that's 16x, and what we're left with are the constants there, plus 30. And you always want to double check your values. You always look back and you say, well, 3x and 3x, yep, that's 6x. 5 and 5 is 10. So that's, yeah, that looks right. 16x plus 30. So, okay, so there's your perimeter. 16x plus 30. Now, part B says you're going to place a post every 2 meters. So, if your perimeter turns out to be this whole value that we call 16x, oh, give me a tool, there we go. So if your total perimeter, there we go, trip around the outside of this rectangle, you start here, you go up here, round and around, and you take a journey. What we found out is that entire journey is 16x plus 30. Now, this is in, let's push this off to the side here. This is in meters. So I'll just say in meters. Now, they place a post every 2 meters. Okay, so as I go around, I'm not counting every meter. I'm putting down a post every 2. So let's see if I can switch up my colors. So every 2 meters, you're going to basically put a post. You get the idea. So how many posts would that be total? Well, if the perimeter is this value, then we are going to put a post every 2 meters. And our final answer should tell us how many posts this would be. Well, look at that. We've got a polynomial divided by a monomial. Seems to be a recurring theme in this assignment. 16, we should get 8x, and we should get plus 15. So how many posts is it? Well, if we look at our overall perimeter and we're going to put down a post every 2 meters, then we would say, this sounds a little bit strange, 8x plus 15 posts. When you actually come along and tell me what x is, if x turns out to be 1, I could say, well, shucks, that'll be 23 posts. But until you fill in what the missing value of the formula is, I can't really know. If x turns out to be 2, then 8 times 2 is 16 plus 15, then we're looking at somewhere in the neighborhood of 31 posts. So there we go. Sort of a large question. Now, as we glance back, we've got quite a bit of pink and blue and red. Okay, folks, that's the end of the notes for section 7-3, dividing polynomials by monomials. Okay, have a good one.